Hi everyone, this will be our video for the remainder and also the factor theorems. We'll be using a lot of synthetic division, so you want to make sure that those skills are sharp for this. Okay, so first up we have the remainder theorem. Now what our remainder theorem is telling us in the mathematical form, it's saying that if f of x is divided by x minus c, so a binomial, then the remainder is equal to f of c. So what this is really telling us that if we were just to plug in that c value, that would be equivalent to our remainder. It's going to be the same value. And that's what we have written down here, that when we find our remainder in synthetic division, it's going to be the same value as if you were to just plug in that c value. So let's look at an example of this. So here you can see that our example is saying it's what is the remainder of, and we have this wild function and we have this function and it's being divided by x minus 2. So I'm going to go through and I'm just going to show you how this works, and you can decide which method you like to use. So we could use synthetic division, and we can get this set up, and when we do, we know that we're going to put a positive 2 on the outside because I see a negative 2, and then we're going to have all of our columns filled out. So we have 4x to the 7th. We do not have an x to the 6th, so we want to make sure we have a 0 there. We have a negative 2x to the 5th. I do not have an x cubed, so I have a 0. Or sorry, that's for the 4th. I don't have an x cubed, that's another 0. And I have a 3x squared. I have a 0x. And then a minus 1 is my constant. So this one has a lot of terms, but also has a lot of missing columns. So you want to be careful that you always include zeros there. So let's use our little methods here for synthetic division. Remember, we're going to add down and multiply up. So I'm going to multiply that by 2 and I get 8. Add down and I get 8. Multiply up, I get 16. Add down 14. Multiply up 28. Add down 28. Multiply up 56. Add down 56. Multiply up 112. Add down 115. Multiply up, 130, that's going to be a 230. Add down 230, multiply up 460, and add down 459. So that's telling us that this value here, not only is it our remainder, but our remainder would also be whatever we get if we were to just plug in 2. So this is our remainder. Let's just try to prove that point for us. So if we take and we want to plug in 2, we're going to have 4 times 2 to the 7th minus 2 times 2 to the 5th plus 3 times 2 squared minus 1. So once you do that, you could obviously take your time, figure out what all these 2 to the powers are, and do your multiplication. For the sake of time for this video, just plug it in your calculator and we get 459. So you can see that this is the same exact value that we got as our remainder when we divided. So here you can see we have a different example. It looks a little bit similar, but now we have a function that has an additional variable. We have an additional missing term here. We have a k that we're concerned with. So we have this function, we have this extra variable here, and it's telling us that when this function is divided by x plus 2, we know that our remainder is going to be negative 18. So we are trying to determine this value of k given the remainder, the divisor, and the whole function except for that one variable. So let's get this set up in synthetic division for us. So we had x plus 2 is what we're dividing by, so I put a minus 2 in the front. Then what I can think about is I need to make sure I have a column for everything, so I have a 2x cubed. I do not have an x squared, so I have a 0. I have a kx, that's my linear term, and then I have a minus 4, that's my constant. So my remainder was also given to us, and our remainder was negative 18. So here's where you need to kind of like start from the beginning and work backwards from the end, and kind of meet in the middle so we can figure out what k is. So starting from the beginning, we're just going to go as far as we can until we hit a roadblock. So we're going to add down, multiply up, add down, multiply up. So here's an idea that you could do if you think more algebraically. You could think that k plus 8 times a negative 2 is going to go in this spot right here. Okay, so that's really what's going to go there because I'm going to add down and then multiply up. So that's one way you can think of it. So another way that we can work on this is from our remainder back towards the center. So we know that whatever this value here is, and now we have a star again, whatever that value there, I had -4 plus whatever that was, so we're just going to call it like a z, just another variable, equals -18. So when I'm working on this, I need to figure out what was added to -4 to give me this -18. So when I'm working on this, I can add that 4, and I would get, let's see here, we would have -18, but we would add 4 to it, so we'd get a -14. So that's really what I could fill in into this last block over here. So I'm going to erase these stars, and I know that a -14 is what really truly belongs there. So I have -14 here. So now I need to think that whatever I had over here, so I'm looking, I had k plus 8, there's going to be some result times -2 would give me this -14. Okay, so I would do k plus 8 times -2 is going to give me this -14, because this is really k plus 8 down here. Okay, so we can work on this like a little algebraically. If this is something simple enough to do in your head, that's fine too, but it's nice to have the organization. That's what's really great about synthetic division. So let's work this out. So I would have k plus 8 is going to equal a +7, which is going to tell me that k is going to equal a -1. So my solution here would be -1. So when you're working on a problem like this, remember we started from the beginning and we did as much as we could until we got to this point. And then we kind of used our remainder to work backwards. And then we just figure out what are we missing, okay? So this is kind of like one of those choose your own adventures. There's no right or wrong method. You could do a different step first. Just make sure that your work is organized when you're working on problems like this, because it can get a little confusing. So here we go. We have the factor theorem now. So in our factor theorem, basically this is like an addition onto the remainder theorem. They go hand in hand. So the factor theorem now is telling us that if you get a remainder of 0, so if there's nothing left over and you have a remainder of 0, then whatever you were dividing by, so x minus c, is a factor. Okay, and this makes sense. Factors are just numbers that multiply to give you a whole number. So something that does not have a remainder. So if your remainder is 0, then what you were dividing by, the whole thing that you were dividing by, is a factor. Okay, let's look at an example of this. Okay, so here we go. We have another example, and this one is now asking us about factors. So obviously we're going to be using the factor theorem. When I'm looking at this and I'm trying to decide if I should do synthetic or long division, you really want to look at what you're dividing by. So this is a 3x. So the issue with synthetic is that it must be like a 1x to the first plus or minus a number. This is a 3x. So I'm just going to do long division just so you can see that done again. Or you could rearrange it to make it, work for synthetic. But long division is perfectly fine. It's not even that much more work. So we're going to get this set up. We're going to have 3x cubed plus x squared minus 20x plus 12 on the inside. And then we're going to have 3x minus 2 in the front. So if you remember from your video from last week, the long division, we kind of have this like little mantra here. We're going to divide, multiply, subtract, repeat. And that's what we're going to do here to get through this problem. So when we're talking about dividing, I'm talking about the first term. So I could do side work. I could do 3x cubed divided by 3x. And that's just going to give me x squared. So that's what my first term on top is going to be. And I put it over my x squared column. And then I'm going to multiply. So then I'm going to have x squared times 3x, and I get 3x cubed. And x squared times minus 2, and I get minus 2x squared. Now we subtract this whole row. First terms cancel, they always should cancel, and then we end up with 3x squared. So then we repeat. Before we repeat, you can bring down your next term, and we'll repeat. So we need to divide again. So 3x squared divided by 3x, and we end up with just x. So that'll go over our linear column. And then we're going to multiply. So we'll end up with 3x squared minus 2x. We're going to subtract this whole line. First terms cancel. And then you can see you have minus 20x minus a negative 2x. That really becomes plus. So this is really negative 18x. Bringing down this minus 12. Then we can repeat. So we're going to do negative 18x divided by 3x. So we actually end up with just a negative 6. It's a constant term. We put it over our constant column. Now we'll multiply. So we have minus 6 times 3x, so that's going to be negative 18x. And then we have minus 6 times negative 2, so that's going to be a plus 12x. So when we do our subtraction here, you can see that we end up with negative 24 as our remainder because our first terms cancel, and then I have negative 12 minus a 12. So I do have a remainder of negative 24. So here's where we can kind of make our solution here, make our answer conclusion statement. So since we have a remainder, since the remainder equals negative 24, let's see, what did we have? We had 3x minus 2 is not a factor. Okay, for it to be a factor, the remainder would have to be 0. So since it's not, it is not a factor. So here is our last example, and it's actually similar to one of our examples for the remainder theorem. The only thing different is they're not actually telling you what the remainder is. They're just saying that this should be a factor, right? They're saying that if this is a factor, what is this missing variable that we have? So we know that if this is a factor, our remainder must be 0. That's what this factor theorem is telling us. So this one we can use synthetic. You see how this is just x minus 2, and just because it's a 1x to the first power, that's good for us. So we can get synthetic set up. We're going to have a positive 2 on the outside because I see a minus 2. And we'll get everything on the inside set up. So we have 2x cubed minus 6x squared. Then we have a plus mx. We don't know what m is. And then we have our 4 as our constant. Now we don't know what m is, but we do know what our remainder is. And because this is supposed to be a factor, our remainder must be 0. So we can work this through just like we did with one of the other examples. We're going to add down and multiply up as much as we can. So we're going to have 2. Multiply up, we get 4. Add down, we get negative 2. Multiply up, we get negative 4. We can also work backwards, right? This is kind of like as far as we can go because down here is going to be m minus 4. Okay, and m minus 4, we don't know what that's supposed to equal yet because obviously we don't have this missing, you know, this little last option here. So you could do this in 2 different ways. I'll do it just like how I did earlier. We can figure out 4 plus what will give me 0, right? So I can figure out pretty much in my head that my missing number on this end here is going to be a negative 4, so that when I add them I get 0. So what I can think about if I want to write this in like a little algebraic, if I take this m minus 4 term, remember we take our term down here, we multiply up to get to that negative 4. So I'm going to multiply that by my 2, and it should give me negative 4. So I can solve for m. I have m minus 4 equals negative 2. I can add 4 and I'll get m to equal 2. You could always check your work by doing this again with a 2 in place of your m and hoping that your remainder remains 0.